Good morning, class 12. Let's continue with the topic. Last class we spoke about redox reactions. I discussed two laws of Faraday of electrolysis. So today I'll be starting with electrochemical cell. Now what is an electrochemical cell? Electrochemical cell is a device that converts chemical energy to electrical energy. Chemical to electrical energy. It is just the opposite of electrolytic cell, because in electrolysis we use electrolytic cell that converts electrical to chemical energy, but here chemical energy is converted to electrical energy. Now electrochemical cell are also known as galvanic cell or Daniell cell. These are examples of an electrochemical cell. The functioning is same, they convert chemical to electrical energy. Now let's see the setup of an electrochemical cell. Setup means what are the things required? What are the constituents of an electrochemical cell? These are my two containers, glass containers. Okay. Now here one metal rod is there. This is my electrolytic solution. Here also I have a metal rod. And electrolytic solution. Okay, then right, so this is my setup. I'll define all the terms here. Let me finish the drawing. Two metal rods are there, two electrolytic solutions are there. Now I'll join this metal rod two metal rods I'll join with the help of a metallic wire to the galvanometer, right? So this is my entire setup. Now what are the terms over here? See, in case of electrochemical cell, we have to remember that the oxidation and the reduction parts. Now when we are talking about electrochemical cell or electrolytic cell, redox reaction is a common. That means oxidation and reduction reaction will be occurring at the same time. But here what is the difference? We have to keep the oxidation part and the reduction part physically separated. That's why these two are separated. This one of them is oxidation part, other one is a reduction part. A reduction is happening. So that two part has to be separated. Now this is my electrolytic solution, that is zinc sulfate solution. Zinc sulfate solution. Zinc sulfate solution means I am going to have here Zn2 plus ion, Zn2 plus and sulfate ions. Okay, throughout. This is my copper sulfate solution. Copper sulfate solution means I am going to have copper 2 positive ion and sulfate ions. Okay, so this is my electrolytic solution. Now these are my rods, the metal electrodes actually. Means one of them is cathode, other one is the anode. Right, so they are the metal rods. Now this is my anode, which is zinc rod. This is zinc rod. That is acting as anode. And this is cathode. That is acting as a copper rod. Now why this is acting as the anode, this is acting as the cathode, that the reason you will do it in later part of the chapter, not here. This is my salt bridge. This is an important part. This you haven't seen in your electrolytic cell. In electrolytic cell you saw electrolytes, you saw electrolytic, you saw the electrodes, right? But here this is the additional one, that is salt bridge. Now salt bridge also consists of some solution. What is that solution made up of? Salt bridge, it consists of saturated solution. Saturated solution of KCl or KNO3 or ammonium chloride. Even small amount of gelatin is also added to give it a semi-solid mass. So this is the basic composition of salt bridge. These are the aqueous solution, saturated solution of either KCl or KNO3 or ammonium chloride. Okay, so this is the entire setup. Now here we'll come across some new terms, that is half cell, redox couple. This you haven't done in your electrolysis part. Now first you have to understand what is a half cell. Now, half cell means where both oxidized and reduced form of the same species are present together. Half cell where both oxidized and reduced form of same species are present together. Okay, now in half cell we have two types. One is oxidation half cell, other one is reduction half cell. Now obviously oxidation half cell means where we are going to have the anode, where oxidation will be occurring, and reduction half cell means where we are going to have the reduction process, that is we are going to have cathode, that will be my reduction half cell, right? So here in this particular setup, this is entire an electrochemical cell. Out of this, one will be your oxidation half cell, other one will be your reduction half cell. So here we are having the anode. So anode means we are going to have oxidation over there. That is always, whether it be electrolysis or be an electrochemical cell. So this will be my oxidation half cell. This will be my oxidation half cell. And obviously other has to be my reduction half cell. This will be my reduction half cell. Reduction half cell. Now from here you understand what is half cell. Half cell means the electrode when placed in contact with solution of its own ions, that represents my half cell. Here electrode is my what? It is obviously it's anode, but anode is what? It is zinc rod, right? So when zinc rod is kept in contact with solution of its own ions, because here we have zinc ions, so that setup is your half cell. Here the copper rod is kept in contact with solution of its own ions. We have CO2 positive ions, right? So this setup is your half cell. So this is my oxidation half cell and this is my reduction half cell. Okay, now the function of the salt bridge. Now together these two half cell, this oxidation half cell and reduction half cell, they combine to form a redox couple because they will undergo reduction oxidation processes. So together these two half cell combine to form redox couple. Okay. Salt bridge function is very important over here. Salt bridge maintains the electroneutrality of these two solution. How it maintains the electroneutrality? Like for example, in this particular half cell there will be oxidation. Oxidation means zinc, means this reaction will be occurring. Zn will undergo oxidation to give you electrons and this one, right? Zn2 plus. So the concentration of Zn2 plus ions will be increasing with time. Now to balance this, what will happen? Negative ion from the salt bridge will come into this solution. Negative ion means either Cl minus or your nitrate will come to balance this positive charge. So the neutrality will be maintained. Here what happens? Here reduction is happening. That means here the concentration of positive ions will be decreasing because your CO2 positive will undergo gain electron to get deposited at the electrode. So this will decrease. So to maintain the charge, to maintain the neutrality, positive ions from the salt bridge will be coming here, either potassium or ammonium. Now depends on the type of solution you have taken in the salt bridge. So that way they maintain the electroneutrality of the solution, of these two solutions. Okay, and it connects these two solutions. These two solutions, they are not physically together, they are physically separated, but it is connected with the help of a salt bridge that completes the entire circuit. Okay, so this is the basic features. Now what happens? Now common things what we know in case of anode, that is in oxidation half cell, we are going to have oxidation, that is this process. Zn will continuously dissolve in the solution to give you Zn2 plus 2 electrons. Okay, so with time the weight of zinc rod will be decreasing and concentration of zinc ions will be increasing and electrons will be getting deposited at the surface of the zinc rod, right? So anode will have an excess of electrons. That's why anode is given here negative polarity. This is the basic difference between electrolysis and this setup. Anode, due to excess of electron deposition, it will be negative, right? Because these electrons are present at the metal surface. That's why negative. Cathode, what it's doing, since it's attracting the electron, that's why it will be given a positive polarity. This is the reason for its polarity. And with time, the weight of the copper rod will be increasing because of this reaction, right? Temperature throughout will remain constant. Both the solution will remain electrically neutral. Okay, and after some time the cell will stop working. That reason again we'll discuss later on. Here one thing, as electrons are released at the anode, they are formed at the anode or they are accumulated at the anode, so the electron will flow the electron will flow in this direction. This will be flow of electrons. Electrons will flow from anode to cathode because anode has excess negative charge, and the current will flow in the opposite direction. Current flows in the opposite direction. As the current flows, we get to see a deflection in the galvanometer, and then only we can understand the some reaction has occurred which has got converted to electricity or electric current. So current flows in the opposite direction. Okay, this is the basic setup of an electrochemical cell. This is an electrochemical cell. Okay, so thank you class. Okay.